It's not every day I come across something that's supposed to be so good. Everyone's raving about it. But the moment you try it, it feels like you're driving a Pontiac. Let me explain. Before we dive in, please like and subscribe if you want more in-depth and insightful videos like this. It really helps keep me sane and motivated when I'm deep into research for these tutorials. Today, we're looking at both the old and the new Framepack models for ComfyUI. We're also going to walk through the best way to run these, especially if you're using older GPUs. And I'll explain the differences between them and why it actually makes sense to keep both versions available. Now, here's the workflow we'll be using today. It's made up of about 7 groups. There are 2 more Framepack nodes I came across, but this specific group is the only one that gives you the option of using both BF16 and FP8 files. That's the kind of flexibility we want. The structure follows my usual ComfyUI layout, with the models on one side and everything else, the sampler, decode, and save nodes, towards the end. I prefer a more linear workflow. It just makes everything cleaner and easier to follow. Let's walk through the workflow quickly so you can see what it's capable of. First up is the Torch compile node. You can only use this node if you have both Triton and Torch version 2.5 installed. If you do, you'll see up to a 30% speed gain. You might remember that we already went over how to install Triton on a Windows machine. That video should either be up here or linked in the description below. In that video, we also covered which GPUs are compatible with Triton. Basically, if your GPU doesn't support BF16, you're out of luck when it comes to that specific optimization. At least you still have Tcache helping you out. We'll get to Tcache a little later. But if you are using a GPU that is compatible with Triton, then all you need to do is enable the Use Torch Group Bypasser node that sits above the workflow. Just turn that on, and you'll unlock around a 30% boost in speed. That's already a solid gain. And since your GPU supports Triton, you can also enable Sage Attention to further reduce generation time. I'm going to go ahead and use SDPA for this example, and I'll disable the Torch compile node. Next, we have the models. You get 2 Framepack model wrapper nodes. I've set the first one to use a base BF16 model, and the second one is running on FP8. And I understand now why Kijai included both in his example workflow. If you've already used the web UI before, then chances are you already have the BF16 models. That's what it defaults to. But the newer models won't work if you just use the standard download Framepack model wrapper node. I managed to get it working, but only by changing the backend of the node. And that's not really a good idea, especially since I have a feeling it'll be updated soon anyway. There are 4 other models floating around out there that you can use. 2 of them are single BF16 models, one for the old model and one for the new F1 version. And then there are 2 FP8 models, again for both the old and new variants. I'll be using the FP8 versions in the second model wrapper node. We'll go over how to download all of those a little later. Personally, I have all the models saved on my system, but for this demo, I'm sticking with the 2 FP8 ones. Just below these 2 nodes, you'll see the same clip and VAE models we used with the HunYuan image to video model. Those are already set up. Then we have the start image and end image groups. I'll walk you through those in a moment. And after that comes the LLM. For this part, I'm using the same if LLM node I used in the Gemini 2 Flash video. This is actually really straightforward. The node basically gives you access to all the models and APIs you'd normally use. Connecting it to an API is as simple as creating a free account with the provider, selecting your preferred provider and model in the node settings, and then pasting your API key into the external API key field. In my case, it's Google, but you can even use Ollama if you want to. It also has a few nice little bonuses. Things like an embellish prompt, style prompt, and negative prompt features built right in. Now, why am I not using Ollama here? That comes down to the load on my system. The framework model plus the HunYuan models are already pushing things. Using an API offloads all of that and keeps everything running smoother. On top of that, you get access to a free, state-of-the-art multimodal model. That's a win. What I did was give it the same system prompt that Liasville uses. The only change I made was to tell the model I only need to add an action or motion in the user prompt field, and then let the LOM handle the rest. The model I'm using here is the Gemini 2.0 model. We already found out in the last video that it's free and super fast. And again, because it runs through an API, it doesn't add any load to my system. That makes a big difference, especially if your GPU is already working hard. Just something to keep in mind. Even though Framepack can technically run on as little as 6 GB of VRAM, It's not the only thing that's going to be using your GPU. Running the LM externally with a free API is one of the smartest things you can do. Another thing that can help is going to the sneakyrobot.org website. There's a section called Free Prompt Generators. Choose the Framepack option and just describe the image you want and what kind of action you want it to perform. It'll give you a prompt that actually works surprisingly well. And while you're there, explore the other prompt generators. I'll have more coming soon. I might even add an option to upload an image in the future. Back to the workflow. The final prompt output node gives you the prompt that the LLM generated. Right next to that, we've got the positive clip text encode nodes. I've kept the positive text encode collapsed because the LLM is already providing the prompt. For the negative prompt, we don't need anything here. It's zeroed out by the conditioning 0 node. Then we move into the sampling group, where you'll find the Framepack sampler. This is where everything comes together. The model, the positive and negative embeds, image data, and the latents. The beauty of this sampler is that it gives you way more control than you get with the web UI. We'll come back to those settings when we test the whole thing out. The final section is the decode and save group. That includes the tiled VAE, the get image size and count nodes, and finally, the video combine group. I always keep my tile settings low. It helps reduce the load on the GPU. Sometimes it feels like the models aren't fully offloading, and I'd rather be safe than sorry, especially when I'm running anything that takes more than 2 minutes to finish. One thing I forgot to mention, the download Framepack model node will automatically download the old Framepack model if it doesn't find it in its folder. But you don't really need that right now since we're using the FP8 versions. Before we test anything, let's first try to understand the difference between the two Framepack models. The main difference is in how each model handles video creation. The old model starts by showing you the last frames first and kind of works its way backwards. That caused a lot of problems, some of which you'll see as we continue with the video. The new model, on the other hand, starts from the first frame and moves forward through the video. That makes more sense, and it's also more stable, especially when dealing with side profile videos. We'll start by using the old model, and then we'll compare it with the new one. We'll also take a look at what needs to be done to get the new model working properly. Let's test this out. I'm going to run 3 tests. One with just a single image, and then another using both the start and end images. To begin, I'm adding one of my cousins into the image load node. Then I'm setting the find nearest bucket node to 512. Technically, I don't have to, but it'll speed up the render, and I'd rather upscale the final video later than wait too long now. I'm keeping the clip vision encode crop set to center. The robot cousin I'm using is already centered, so there's no need to change that. Then I'm bypassing both the enable framework official group in the model selector node and the enable end image in the image input bypass node. Now, the prompt I'm using here is simple. It's just the action or motion I want the character to perform. In this case, wave and smile, then walk toward the viewport. Let me explain the settings next, starting with the ones for the language model. The settings for the LLM stay exactly the same. I'm using Gemini and the Gemini Flash Experimental. Nothing changes here. Now we're looking at the part I mentioned earlier, the inference steps. These steps work the same way they do in most AI tools. More steps generally give better results, but they also take more time. The default is 25, so I'm leaving it there for now. At a certain point, you hit diminishing returns, where the quality barely improves even if you add more steps. Keep that in mind. One thing you should not touch is the configuration value. We're using a setting of 1 for the CFG scale, and that needs to stay exactly as it is. Please don't change that. The guidance scale is currently at 10. That's fine for now. The seed is set to default, but if you want to try something new, randomizing it can help you find results you might not expect. And sometimes that's where the magic happens. Next up is something really important, GPU memory preservation. This is actually one of the reasons I prefer using the wrapper over the web UI. You have better control over how much memory is being used. My advice? Always set this about 2 to 3 gigabytes below your card's total capacity. So if you're using an 8 gigabyte card, aim for 6 gigabytes. If it's a 12 gigabyte card, leave it at 10. The more VRAM you have, the more headroom you want to leave so your system can run smoothly in the background. You don't need to dedicate your entire GPU to Framepack. Let me put it this way. If your card has 24 gigs, you don't need to throw all 24 at it. Between things like Tcache and Sage Attention, even 20 gigs can be overkill in this case. Before we move on to the last setting, I want to be clear about something. Your GPU isn't the only thing that matters here. Run Framepack and check how your memory is actually being used. There are people with 40 gigs of system RAM who've still run into problems. You want to have at least 30 gigs of system RAM available if you're aiming for a smooth experience. Everything needs to line up just right if you want Framepack to deliver what it promises. And yes, I know some people are going to say they got it running with this or that workaround. But for every one person who gets lucky, there are 5 to 10 others running into problems. That's just been my experience using the web UI. Now let's talk about the setting that really makes Framepack interesting. The ability to generate long video. To test that, I'm setting the video length to 15 seconds. We'll see how that turns out and maybe go even longer on the next run. Now I'll queue it up and let's see what we get. This looks amazing, especially for an FP8 model. The motion turned out better than I expected, even if it did take a while to finish. So if your render takes 30 or 40 minutes to complete, don't worry. You're not doing anything wrong. But here's where the original Framepack model starts to show its limits. Right at the beginning, during those few frames before the character starts moving, you'll notice it's like it's thinking about what to do before actually doing it. Now let's try the same test again, but this time with the new F1 model. I'm switching the model over to F1, keeping everything else exactly the same. Let's see how this compares. Honestly, I kind of liked what the first one gave me. But that could be because I'm using Tcache, and maybe that's having an effect. Now for the next test. This time, I wanted to try something a little more complex. But we're going to have to settle with a sequence of a boy jumping off a chair, and then another image of him landing smoothly on the floor. First, enable the end image input. Then I load the image of the boy mid-jump into the start frame, and the image of him landing goes into the end frame. This sets the motion path for the AI to interpret. Next, I add the prompt jumping off the chair. Just a clean and simple instruction. I'm increasing the steps to 30 and keeping the duration at 15 seconds. That way, we're giving the AI enough time to animate the motion without rushing it. The expanded prompt it generates from that is the robot jumps off the chair, landing smoothly with agility. Let's queue it up and see what we get. This is not quite what I hoped for. I actually think I got better results when I only used a single image. But that's part of the experience. It's free, and AI doesn't always nail it on the first try. This render took about 30 minutes to complete, and it still struggles with that same issue at the start of the video. Those few awkward frames where the AI seems unsure of what should happen before the motion kicks in. Now I'm switching to the F1 model. The settings stay exactly the same, but something clearly went wrong this time. The output completely broke down. I don't know why I picked such a difficult sequence for this test. I probably would have been better off with something simple, like a woman walking alone through a quiet street, but we went for it anyway. Let's try one more, just for fun. I want to see how it handles action. This time, I'm working with 2 images of boxers. In the first one, the boxer with the black gloves lands a punch. In the second, the boxer with the red gloves counters with his own. For the prompt, I'm just going to use one word, boxing. That single word gives us a generated prompt that reads the boxers exchange rapid punches, creating a flurry of motion and impact. Let's see what that gives us. This time, it's getting better at handling action. You can actually feel the rhythm of the punches. But once again, the F1 model struggles here too. It's just not delivering the responsiveness or timing we need for quick sequences like this one. We'll talk more about why that is once we go through the installation steps. Like I said earlier, getting perfect results on your first run. Almost impossible. The best way forward is to try a few runs and pick the one that feels right to you. Now what I'm going to do next is walk you through the entire installation process, step by step, so you can get the latest version running. There are basically 3 different models you can use for this setup. The first one is the model package that comes with the web UI installation. You can also download this manually from the Liseville Framepack Hugging Face repository. Or you can do it by simply loading the workflow, disabling the FP8 setting, and connecting the Download Framepack model node. Once you queue the workflow, it should automatically begin downloading the model. Right now, this approach only works with the older model. The Download Framepack wrapper is still linked to version 1, so the F1 model is still not available through this method yet. We'll use the FP8 model by Cabotuha to test the F1 model. And to be honest, I don't think you need the original Framepack files if you already have access to these updated models. I'll still walk you through how to download and store the originals on your drive in case there's a workflow update that makes use of them later on. The workflow itself is going to look exactly the same. What will likely change is the underlying code. So if you already have the web UI installed, you can copy and paste your existing models directly. Here's how that works. Go into the following path on your computer: Framepack, Web UI, Hugging Face Download, Hub, Models, Liasville, Framepack i2vhy. Then go into the folder with a long string of numbers. Inside that folder, you'll see symlinks. Copy those files and paste them into ComfyUI, Models, Diffusers. But before you paste them, create a new folder inside Diffusers. Name that folder Liasville, then inside that, create another folder named Framepack i2vhy. That's where the files should go. This step might take a while depending on how fast your PC transfers files. If it looks like it's frozen at first, don't worry. It's copying the entire file before showing progress. That delay is normal. Now, if you don't already have those files on your system, you can use a downloader to get them one by one. I use Internet Download Manager for this because it lets me resume downloads if something gets interrupted. That's much faster than trying to clone everything from Hugging Face using Git. But if you want to go the cloning route, especially on a Windows machine, here's how to do that. First, download Git large file storage. Install it. Once that's done, open the Start menu, search for CMD, and open the command prompt. Inside the command prompt, type git lfs install and hit enter. If it works, you'll see a message that says git lfs initialized. Then go back to the Framepack Hugging Face page. Click the small 3-arrow icon next to Use this model, then choose Clone Repository. A pop-up will appear with 3 instructions. What you want is the second instruction. This one clones the entire repository. Copy that git command. Next, go back to the ComfyUI directory, open the Models folder, then the Diffusers folder. Inside the Liasville folder you created earlier, delete the Framepack i2vhy folder. Right-click in the empty space and choose Open in Terminal. Paste the git command you just copied, hit enter, and it will start cloning the whole repository directly into that folder. You'll see a message saying, Done. But that's just for the smaller files like configs. The larger files take more time, so just be patient. This method is the most reliable if you want to grab everything from a Hugging Face repository in one go. You can use this exact same process for the Framepack F1 models. Just make sure to store them on the same drive where you installed ComfyUI. That way, once there's an update, you can easily drag and drop or cut and paste the files into place. Now let's talk about the single, smaller FP8 and BF16 files from Kijai and Cabotuha. Click the link in the description to go to the download page. Download the FP8 version and place it inside ComfyUI, Models, Diffusion Models. I created a folder called Framepack inside Diffusion Models and dropped the FP8 file in there. You can do the same to keep things organized. The text encoders, Clip Vision, and VAE used here are the same ones from Hinuan. If you don't already have them, click the link in the description to open the ComfyUI Hunyuan repackaged Hugging Face page. Once you're there, go into the Split Files folder. Inside that, you'll find the text encoders. Download both the Clip L and the Lava Llama 3 FP8 scaled or FP16 models. Once downloaded, place those inside ComfyUI, Models, Text encoders. Then download the VAE file. It's also in the Split Files folder. Once downloaded, place that in ComfyUI, Models, VAE. Now for the Clip Vision model. This is the only file you'll need to get from somewhere else. Click the link in the description, download the SIG clip file, and place that inside ComfyUI Models, Clip Vision. That wraps up the file prep. Before you load the new workflow into ComfyUI, you need to update ComfyUI itself. Open the Manager tab and click on Update ComfyUI. This will pull in the latest version of the user interface. Once that's done, restart Comfy. Then drag the workflow file into the workspace. Now you're officially ready to start using Framepack. So what do I think about Framepack? At first, I was skeptical. After spending weeks testing open source models and apps, trying to find the right combination for the desktop YouTube video assistant app I was building, I had started to notice a pattern. A lot of these models tend to overpromise and underdeliver. They look flashy, sure, but underneath it all, they're just giving us what we already had, but in a flashy new raincoat. But Framepack surprised me. It's not just another recycled model. If anything, it feels like it's sitting right on the edge of something great. It would probably be a killer app if it integrated one. But even without that, it still manages to be useful. Or should I say somehow useful? And the only reason I say somehow useful is because of one factor: GPU support. Let me break it down. Right now, the most common GPUs people are using are the 3060 with 12 GB of VRAM and the 4060 with 8 GB. What's odd is that Framepack actually performs better on the 4060. That might seem counterintuitive, right? But the reason is technical. The 4060 supports both Triton and Sage Attention natively. The keyword here is natively, as in right out of the box without needing workarounds. The truth is, if you're on a 30 series card, your GPU probably isn't natively ready for these features unless you're using a server-grade card like the A100s or the H100. That's just how the support is structured right now. Even with those limitations, I still believe Framepack is one of the best at what it does. As for why the F1 performs badly, I believe it's because the backend for the node still treats it like the first model. If your tests on the F1 model haven't gone well, that might be why. Again, try it out. If the stars align, you'll get great results. If not, that probably means you're running a 10 series or 20 series GPU. In that case, use the FP8 version from Kijai and Kabachua. It's slower. Yes, it might take forever, but it works. That's where Framepack is right now. Imperfect, but promising. It's not a miracle tool, but it's not hype either. It's doing something different. And if you take the time to experiment and adapt, you'll start to see why that matters. Thank you for sticking with me through this breakdown. Please like and subscribe for more detailed, honest walkthroughs. I'll be here every day, diving into tools like this and showing you exactly what works, what doesn't, and why. This is the Sneaky Robot, signing off. See you in the next one.